personal finance practice problem using OneNote. Rule of 72 and running balance calculation problem number 2. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side, the Practice Problems tab, down in the 1115 Rule of 72 and Running Balance Calculation Problem number 2 tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area, same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we then have our information up top. We're going to look at the calculations on down below, information saying that we have yearly earnings percent of an investment is going to be 12%. So we are imagining then that we have an investment which we could think of as either stocks, it could be something that's in a savings account, it could be bonds, it could be a home or land or something like that that we imagine is going to be going up over time, estimating then that it will be going up annually by 12%. Knowing that, how long will it take for the investment to double? So we're going to think about how long it will take to double. We'll first use the rule of 72, in which case we don't even need an original investment amount in order to estimate how long it will take to double. But knowing an investment amount can be useful, so then we'll give an investment. If you're using a book problem and you're trying to think about what's going to happen and they don't give you an investment amount, then you can always kind of come up with one that you can then work the problem with. And usually you'd use like 100 or 1,000 so that you can have a nice even number to work with. We're going to choose 2,000 here because we did a similar problem in the past with 1,000 just to have a different number that we're going to work with. Let's first do the rule of 72. Now the rule of 72 is straightforward. We're basically going to be taking 72 divided by the 12 here, but it's a little bit confusing to know about how the 12 is going to be formatted given the fact that it's an interest rate and it could be formatted in the format of a decimal, but they want it in the format of just 12 to make the rule of 72 work. Also, we just want to put it in the format of a table to practice our skills of doing so. So let's take a look at a table down below. As we think about the table, we want to basically have the idea that if we were to do this in Excel, we'd be pulling the information from our data table up top. We do these calculations in Excel. So if you want to take a look at those, they're a little bit longer. We go through some Excel skills, but they're useful to do. The rule of 72, we're going to start with the 72. That's going to be part of the rule, so it's not in the data set because that's just part of the calculation. And then we're going to pick up our rate. I'm going to pull the rate into the inside here because although we're going to be dividing by 12, it's not really the 12%. And just remember that 12, of course, when you're talking about a percent, can be represented as a decimal, 0.12 as a percent, 12% with a percent sign. If we want to convert it to 12 in terms of just a dollar amount of 12 or just a number of 12, then we would typically multiply it. Technically, you can multiply it times 100. 12% times of 100 or 0.12 times 100 would give you the actual number of 12. Then you apply the rule of 72, which would simply be 72 divided by 12, giving you that magic rule that approximates the time period that it would double, in this case being 6 years. Again, so in other words, if I type this in the calculator as 0.12, that would be 12% in decimal format times 100. We get the actual 12. Then we can take the 72 divided by the 12. We get 6 years, which is an approximation of how long it would take for something to double if the interest rate was to 12%, no matter what the amount of the investment was. If we assume the amount of the investment is 2,000, it would take approximately 6 years, we're assuming, given the rule of 72, for it to double to 4,000. Let's go ahead and look at that another way. We're going to do that with the running balance now. This is another thing quite useful to be set up in Excel. You'll note that the rule of 72 is kind of magical in that it gives you that one number, and it's also restrictive. It also doesn't give you the detail about the actual interest as it accumulates upwards on a year-by-year basis. If you do something like a running balance, difficult to do just by hand, not difficult, but time-consuming to do it by hand, not difficult to do in something like Excel or a spreadsheet program. It'll give you a lot more detail, so it's really worthwhile to do that. Highly recommend checking out some of these problems in Excel to see how to set those up, to see how to copy and paste and use the autofill feature to set them up easily. So We're going to then say that we have periods 1 through 7 years, and we're just going to simply calculate our interest as we go down the table. So all we're going to do is set up our years on the left, interest calculations in the middle, and the investment on the right. So if I talk about year 0, then we're going to start off with our 2000. So there's our 2000. That's our starting point. We're going to multiply that times the 12%. 2,000 times the 0.12 is going to give us interest of the 240 for year 1. If I take that 240 plus the 2,000 starting point, that's going to give us then the 2,240. There's the 2,240. If we take that, then our new starting point, multiply it, because it's compounding at this point, times the 12% times 0.12, we're then going to be getting the 268.8, which we can then add to the 2240, getting the 2508.80. We can continue this process on down. It now compounding. We're going to take that and multiply it times 0.12. We're going to get the 301 and then 6 cents about. And we can add that, of course, to the prior balance, the 2508.8. And we're going to get then to the 2809.86. We can see the interest going up as we go due to the fact that the principal investment is going up and the interest is compounding on it. So we're going to then take this and multiply times the 0.12. We get then the 337 and add that then to the 2809.86. And that's going to give us then the 3147.04 about. Taking that and multiplying times 0.12 is going to give us the 377.64. We can take that and add it to the 3147.04, giving us then once again the 3524.68. Taking that and multiplying times 0.12, we're going to get the 42296. Adding that plus the 3524.68 is going to give us then the 394765. Taking that times the 0.12 will finally get us to the 473.72 about. And then we're going to take that and add it to the 3947.65. That then clearing us over the 4,000, meaning we doubled the investment because we started at 2,000. So sometime between year 6 and 7, we go from 3,000 to 4,000, clearing the hurdle. So we have indeed doubled it sometime between year 6 and 7. Note the rule of 72 is an approximation because it was 6 as exactly that it came out to. It's not exactly 6, it's a little bit over 6. Note that we can use this calculation here in order to get more exact if I wanted to look at the fraction of a year that's happening between 6 and 7. I'm not going to get into that in more detail right now because we'll do that more specific calculations later. Right now, we just want to note that this running balance calculation, no matter what format you use, is useful. So in other words, if you use the rule of 72, if you use functions in Excel, or if you use present value tables or mathematical formulas, they will all be limited in that they'll give you kind of an answer without the details of what's going on with it. Running balance tables gives you a lot more detail in terms of the compounding and gives you a real feel for what's happening with it, which can be quite, shocking. You can see how it grows can be something that you got to see, with a table to really see what is happening. That's really useful to do. Oftentimes, it's useful to know what the interest is per year. It's also useful to know that if you're thinking about something like tax implications with these kind of future value and present value calculations as they relate to personal finance.